Okay, next question we're going to look at is from June 2012, questions 2 and 8. Now, question 2 is saying the price of a pencil is X, a ruler is Y, and a rubber is Z. Leslie brought 3 pencils, 2 rulers, and 1 eraser, and 1 EA. Just put it all into pence there. Ben was 4 pencils, 1 ruler, 1 eraser, and he was 155. And Daniel was 5 pencils, 3 rulers, and 1 eraser, and he was 265. Now, the good thing about these equations is these z's are all the same, so you don't have to worry about that, making them the same. So just pick 2 pairs of equations. It doesn't matter which 2 you choose. I will choose equation 2 and equation 1. Equation 2, writing it out, and equation 1. It doesn't matter which way round you write these, as long as you're eliminating them by subtracting, get rid of the z's. So x minus y, you subtract those two, equals minus 25. Call that equation 4. Pick another pair, and it doesn't matter which 2, so I'll go for equation 3 and equation 2. Equation 3, just writing that out, and equation 2. 4x add y plus z equals 155. Draw your line, subtract. So 1x plus 2y, they disappear, equals 110. Call that equation 5. So writing out 4 and 5 beside each other to see what we have. And again, we're very lucky in this question because if you notice, the x's are the same. So you don't have to multiply, you can just do straightforward subtraction. X minus x disappears. Minus y, take away 2y is minus 3y. Minus 25, take away 110 is minus 135. Just change all signs. So 3y is 135 and divide by 3 at the end, 45. Take that 45 and sub it into any equation. I'll go in for equation 4. So x minus y is 45 equals minus 25. Just bring this across and add it on, gives you x to be 20. And then sub it into one of the equations from the beginning. I'll just use equation 1. So equation 1 is 3 times x plus 2 times y plus z equals 180. So that's 60, add 90, giving you 150. Add z equals 180. So z equals 30. And that's your 3 answers. Next question we'll look at in this paper is question 8. So we'll just scroll down to find it. A curve has that equation and a second curve has that equation. They do not meet. But what you do at this stage is you assume they do meet. So you look for the intersection. The intersection is when you set both curves equal to each other. So I'm going to set them equal to each other. It's a quadratic equation, so everything goes on one side. Bring that across, so it's x squared plus x squared minus 4x, take away mx, plus 6, take away 5. Tidy that up. 2x squared minus 4x minus mx, add 1 equals 0. Now, you were told the equations don't meet. So that means if you work out the discriminant of this, it's going to be under 0. Now, your a is 2, your b is what's in front of your x, so it's minus 4 minus m, and c is the number on its own, which is the 1. So b squared minus 4ac less than 0. I'm going to put brackets around that because there's more than one term. 4 times 2 times 1. To square your brackets, square the first, double the product, so the product is positive 4m, double that, positive 8m, and square the last. Take away 8. Just tidy this up. M squared plus 8m, add 8 less than 0. Now, that doesn't factorise, so use your formula. A is 1, B is 8, C is 8. So m is minus b plus minus the square root of b squared minus 4ac all over 2a. So m is minus 8 plus or minus 64 minus 4 times a times c all over 2a. So that gives you your critical values of minus 8 plus or minus 64 take away 32 is 32. 32 breaks down into root 16 root 2 over 2. So minus 8 plus or minus 4 root 2 over 2. Dividing in ordinary numbers by 2, so minus 4 plus or minus 2 root 2. Now if we look at our wee diagrams, we always have to do in inequalities. Just drawing this out here. So you have minus 4 minus 2 root 2, minus 4 plus 2 root 2. If you look there, it's a positive quadratic. You want under. So your answer is between these two values. And just put a box around the final answer so the examiner can find it nice and easily.